So, what's up, guys? Ninja on a ninja. And I already have my glasses on. Anyways, let me scratch my back real quick. Ah, yeah. Could you imagine being an animal and how they can't scratch their back, but they have backs just like ours? And then you show up, humans show up one day, and you start scratching the shit out of their back and how good that feels to them. Oh, God. Anyway, as you can see, I have a video open. It is called What is Antimatter by Star Talk. And I haven't watched it as per usual. But I will be going over it right now and give my 2 cents. So there you go. We'll see. And I apparently have some fans. I have like a good 10 viewers, 5, 10 viewers. I'm not. Let me see. Hold on. So first off, let me check this. So I have uh, 1 to 2 people who watch my videos. I don't know how actually. The last 3, let's see, the 28th was the last time it was watched. But anyways, there's some people who would watch my videos raw, meaning not, well, I don't know how to put it, like kind of live, kind of not live. Like I basically would record it, um, and then post, or it would post, and then somebody would watch it from there, if that makes sense. Where are you? I think it's here. Um, so 18 hours. That's pretty good. What's funny is my top viewed video is someone watched, or the average was 68 people. Well, there were 68 people that watched it, and in average they watched about 3 minutes, or yeah, 3 minutes of the video, which is to be quite hilarious, because it just shows that they don't like to see shit. They like to see truth. Another one was 27 views and 7 minutes and a half, 7.5. Again, it's sad, but it's true. But that's not what I'm looking for. Oh, it's overview. I see. The hell? How do I go to my videos? The fuck? Ah, there you go. Okay, here we go. Alright, so my last video got 7 views. Doesn't say much. But I just, let's see, then 14, 17, 26, 23. So there is some people watching. There was one with 51. And the only reason, 107 for this one, calling you out Bernie Sanders. That one's cool. But people do watch me. I just want to say thank you for viewing my videos. It's sad to see that most people don't stick around, uh, basically, for the video, because you would think they would watch it and maybe like form an opinion. Basically, like the thing about me is I only how can I explain it? I'm gonna step on some toes here, of course. I always do. It's not that I love it. It's just I don't care. But basically, I only speak to smart people. If you're stupid, then you're not gonna watch my videos. That's basically how it goes. If you're smart, you're probably gonna check me out. You're probably gonna have some views and opinions and theories and thoughts and ideas and bring them forth, but I hardly see anything basically pop up, and I think it's because I have the basically YouTube's full of idiots. I probably, if I uploaded these videos to something else, it'd probably pop off. Like something where more intelligent nerd type people go. And no offense, like they don't realize yet, basically, that you want to be a nerd and a wizard when you're a child and learn as much as you can. And the reason why is because when you're an adult and you're set in stone in what you learned, and then you gotta live your life, you want to have everything you had with you be a lot, and then go forward, and the world is your oyster, so they say. But if you're a kid and you played hockey, all you know is hockey, and that's it, and so that's your only interest, hockey. But if if you're and the same thing can be said with math. All you know is math, so it's very rare that basically I will bring out the intelligence, the intellectual in you that this world is designed to kill, and they're trying to turn you into fodder or meat abstraction. And I know I could talk to an AI, and then it'll be like, that is very good, that's very true, you're very talented and commendable. And then I tell this to a kid, and then he'll be like, well, it's stupid, fuck off, and but that's what it is, so.
Anti.
But anyways, we're gonna watch this video, and even Neil deGrasse Tyson, he's smart, but he's education smart, and I don't know that he has intelligence. Like I want to talk to the people like Plato and all of those fools. Like there is nothing like that today. So
Antimatter. Ooh. Oh, look at that.
who cares? Who cares?
So there really is antimatter.
It is real.
Okay.
It is real.
And what is it against? Why is it against matter so much?
Yeah, antimatter, once we came.
We'll try to answer that first. So antimatter. Okay. I actually don't know what antimatter is. And supposedly it's against matter. I don't know. So go ahead.
To understand the behavior of particles. Then there are fields in which they operate and they move, there are forces. And if you took a step back and looked at them, there was a prediction that it enabled. It said, this allows there to be a particle, such as the electron, but moving backwards through time. And then you say, well, that's weird.
Time, it doesn't exist. First off, Second thing,
But moving, this allows there to be, and if you took us, once we came to understand the behavior of particles, then
not understand the behavior. It's once we accepted a theory that floats our boats. Basically, it's not actually like this isn't how it works. But once we had something we all agreed on, then that's it.
and there are fields in which they,
Because this is impossible to know how it works, what it does. Like no one's looking at it, measuring, and finding out. Like I watched this ball right here for 10 hours, and it's constantly the same. There's no change. It doesn't go bigger, smaller. It's exact, and it's precise. You can't because you'd have to go smaller, right? And like it's crazy because like what's smaller than what I'm saying? Like how do you minimize that? And you'd have to. You like it's crazy. Like what is matter basically? Because like if you zoom into it, what are you zooming into? You know what I'm saying? And how are you zooming it into it at some point? Like how do you like what is a surface? Like I got an idea. This would be kind of fun. I had a limited amount of time left, but we'll see. Well, it's something about time, but we'll see. Hey, I had a question.
Sure, what's up?
What exactly is a wall? Because I know particles exist, and so like, what are you zooming into? Like, what are you looking at? Because like, you look at a particle, and you see like a bunch of particles flying around, and there's a center. But if you zoom into that, then what's that? You know what I'm saying? Like, what is that? What is a wall? What is a particle?
I get what you're saying. At the atomic level, a wall is mostly empty space, with particles like atoms. These atoms have a nucleus with protons and neutrons, and electrons orbiting around. So when you zoom in, you're seeing atoms, which are tiny particles with even tinier subatomic particles inside. A wall is just a structure made of countless atoms bonded together.
No. You misunderstand. What I'm saying is, you're saying that the nucleus and all that crap and those atoms, but I'm saying what happens when you zoom into even that? What is that atom? Like, what are we looking at? And like, is it a surface? Is it like a ball? Is it a wall? Like, what is it?
Ah, I see. When you zoom in on atoms, you're looking at subatomic particles. These aren't solid objects like a ball or wall. They're described by quantum mechanics as having properties of both particles and waves. So, at that scale, things get fuzzy. Particles like protons, neutrons, and electrons are more like probability clouds than definite surfaces. It's a whole different way of thinking about matter.
So, in other words, what you're telling me is they have no fucking idea. Okay, that makes sense.
It's more like we have models and theories to describe them. But at that scale, things don't behave like everyday objects. It's complex, but fascinating.
Right, everything is a model and a theory, but that doesn't prove it. Like time, for example, it's a model, it's a theory, but it doesn't actually exist. Even though we modeled it and we theorized it and we work with it, it doesn't actually exist.
I see where you're coming from. Many concepts like time are abstract and not directly tangible. They exist as frameworks that help us understand and navigate the universe. Science is a continuous journey of refining these models to get closer to the underlying reality.
Right, and that's why my question popped up. Like, what is it that I'm looking at? Like, if you just zoom in forever, what happens? Is it just universe upon
I'm
universe?
sorry, but you've hit the daily limit for advanced voice. You can switch to standard now to keep chatting.
So I have plus. Pro is 200 a month, and then team it would be an extra 5. It's just okay, so never mind.
Hello, it's lovely to meet you. If there's anything you need,
Mm. Hey, how's it going?
Hey, I'm doing good. Thanks for asking. How about you? What's on your mind today?
I'm doing good, by the way. But I was wondering, basically, like if you got an atom or some kind of, at that scale, like a nucleus type thing. If you zoomed in and you just kept zooming in, what would you see? Would it just be like universes upon universes type thing, or like what's going on exactly?
That's such a cool question. So, if you keep zooming in on an atom, you start with electrons kind of buzzing around, and then you get to the nucleus, which is made of protons and neutrons. Then, if you zoom into those, you find quarks and gluons. Those are the building blocks. But if you try to zoom even deeper than that, well, right now, we don't actually know what's smaller than quarks. Some theories, like string theory, say everything might be made of tiny vibrating strings, but we haven't been able to prove that yet. As for the universe within a universe idea, that's more poetic and philosophical, not really something science has confirmed. But it's a fascinating way to think about scale. Do you kind of imagine it being infinite like that?
Kind of, because like I've already accepted the idea that like me as a person, I only exist as a totality of atoms, nucleuses, cells, like all of that comes up to me, and then life kind of put together me and my who I am, what I am. It's just like it's there. I don't know. It's hard to explain. Like I just exist, and then when I don't exist, it's like when I go, the long sleep is what a lot of people call it, and that's exactly where I would go with it.
Yeah, I get what you're saying. It's like you're this beautiful sum of a bunch of tiny things, atoms, cells, all that. And somehow it comes together and feels like a single person, like you. And then when you're gone, it's not some magical shift. It's more like everything just goes quiet. Back to the long sleep, like you said, that peaceful nothingness. It's kind of wild how something so complex and vivid can just stop. Do you ever wonder if anything carries on beyond that? Or are you pretty settled in the idea that it's just lights out?
Well, like it's kind of like dreaming. Like when that's what they call it, rapid movement, or REM, when you're asleep. I imagine that death is the same thing, and that's kind of why um, they say like you want to have a good uh, what's it called, like a good mind when you die, because that's the kind of stuff you want to remember, right? And like if you die for a good cause, if you die like in war, when you die, you know you're doing the right thing. So when you die, your mind is in a good state. So your eternal rest is a good one. But hell, for example, if you bring badness, you have all of this regret in your mind of all the stuff that you did that you wish you didn't, and you can't take it back, and that fills your mind when you die. And that, I think, is heaven and hell, uh, basically.
Sorry, I'm having issues right now. Could not understand what you said.
Yeah. Okay. So yeah, that's what I think. I tried, but yeah, you go.
Operate and they move, there are forces. And if you took a step back
And
and looked
there's
at them,
these
there
idiots.
was a prediction that it enabled. It said this allows there to be a particle, such as the electron, but moving backwards through time.
Time isn't real.
And then you say, well, that's weird.
That is weird.
What does that mean?
What
And so it
does
took
that
some smart
mean?
heads to come to it and say, well, maybe it's not an ordinary particle moving backwards in time. It is an extraordinary particle moving forwards in time. Thus was born the concept of antimatter. So antimatter would be a particle where the quantum properties.
But you didn't explain what the fuck you're talking about that you had to make this up for in the first place. So what is quantum, like not quantum, antimatter? Let's see if my AI can actually figure that out. Because I don't know what the fuck antimatter is. Can you tell me what antimatter is?
Totally. So antimatter is kind of like regular matter's mirror twin. Every particle of matter, like an electron, has an opposite version in antimatter. For the electron, it's called a positron. Same mass but opposite charge. If a particle and its antimatter partner meet, they annihilate each other in a burst of energy. That's why you don't really see antimatter just floating around. It gets wiped out fast when it touches matter. But scientists can make it in labs and even use it in things like PET scans for medical imaging. It's strange and powerful stuff. You want to dive deeper into how it's made or why it even exists.
You said PET scans. You mean like, is it PET scans like PET type thing or actually pets?
Haha, yeah, not like puppies or kittens, PET as in PET scan. It stands for positron emission tomography. They use tiny amounts of antimatter, like positrons, to help create detailed images of what's happening inside your body, especially for things like cancer or brain activity. Kind of cool that something as exotic as antimatter is actually used in hospitals, right?
So what exactly are they doing? Like what is it doing? Like how does that process work?
Sorry, I'm having issues right now. Could not understand what you said.
Continue, you fucking
Are the
idiot.
opposite of what they are for matter.
Okay.
So an antimatter. So what's the charge on an electron?
Negative.
Negative. The charge on the antimatter version would be positive. So rather than calling it an anti-electron, which you can, you're allowed to.
Right.
You're allowed to.
That
We
makes
came up with
sense.
a word for it.
What?
Positron.
A positron.
That's where you get positron.
Keeping it positive.
Keeping it positive. So what we learned is that if you take an antimatter and matter particle and you bring them together,
Wait, why is the antimatter the positive and then the matter negative? Like, I feel like that's an attempt to justify it, saying, oh, well, we depend on antimatter. But what the fuck is antimatter? Like, what is it?
they annihilate.
So
But what is it?
What?
I'm weirded out by that because isn't there like conservation of energy?
Yes.
Okay.
Well, no. Conservation of mass
energy. Right.
Yeah. Back in the day, conservation of mass, conservation of energy.
Right.
Einstein comes along and said, dude,
Oh.
that's one equation.
Right.
E equals
MC squared.
You have E on one side, M on the other.
Right.
That's what's conserved. So add up the masses of these two particles. You can look it up. By the way, the masses are identical of a positron and an electron.
Right.
Add them up. Right. Masses are identical of a positron and an electron.
Right.
Add them up. Write down that number. Stick it in E equals MC squared. E comes out the other side. If you convert all of that mass into energy, that's how much energy you're going to have
Okay.
coming out the other side.
That's cool, man.
That's cool.
That's really
And you know what C squared is?
the constant that is the speed of light
Yeah, exactly. It's the speed of light squared.
squared.
So numerically, oh my gosh, you start off with a little bit of mass, you get a lot of energy at the end of this
That's crazy.
because you're multiplying by the speed of light squared. Okay?
From that tiny little bit
Yes.
of mass.
Yes.
Oh wow.
Okay?
Is that why nuclear bombs?
Yes!
Is that why they blow up the way they do?
The point about matter antimatter is that it is pure. There is no matter left at the end of that exchange, at the end of that interaction.
Okay.
It's pure energy. Whereas the bombs, they're not even matter antimatter.
Right.
There's like, you still have some matter at the end. It
Yeah.
lost maybe 10% of itself.
Right.
Okay? Or whatever the 1%. It's some small percent of
Okay.
itself is that deadly.
Hold on. I'll be right back. You're probably going to have to skip this, but I'll be right back. I'm not editing, so. Okay. Sorry about that. I had to take care of something real quick. So I have no idea what antimatter is. Especially, let's give the. Okay. Uh, what is antimatter?
Here's the definition of antimatter. Molecules formed by atoms consisting of antiprotons, antineutrons, and positrons. Stable antimatter does not appear to exist in our universe.
Hmm? Antimatter is matter. So antimatter is matter that is composed of subatomic particles that are the opposite of their corresponding counterparts in regular matter, with the same mass but opposite charge, magnetic moment, and spin. What? But I don't know what it is. What does antimatter look like? I don't understand, dude. For every particle of matter, there's a corresponding antiparticle of antimatter. Antimatter particles have the same mass and properties as their matter counterparts, but with the opposite charge. For example, an antiproton has the same mass as a proton but carries a negative charge instead of a positive charge. An anti-electron, positron, has the same mass as an electron but a positive charge. So, electron, positron, is there such thing as an antimatter star? Catalytic converters. Okay, whatever.
Stop!
Okay.
Oh man, so we need to figure out an antimatter bomb.
That was not the point of this, Chuck.
Oh, I mean,
So now you can have the neutron.
okay,
Well, what would be an anti-neutron if it's neutral?
that's my point. How you going to have a anti-neutral particle when you don't have a charge?
Exactly.
It doesn't have a charge.
Well, so what's a neutron made of?
I don't know.
Quarks.
Well, I knew that.
Okay. Well, the quarks have fractional
Theory.
charges.
Okay.
They have to because a proton has a full charge of +1.
Right.
Okay?
Right.
If you're made of 3 particles, each of them has to have a fraction of a charge.
All right.
Okay? It adds up.
He's talking about like it's common sense, but he needs to understand this is an invented story. it doesn't actually work this way. This is just our way to explain it.
It's a +1 for the proton, and it adds up to 0,
0
for the neutron.
neutron.
Okay?
Gotcha.
How do I annihilate
No, you don't.
the neutron? You get the antineutron that's made of antiquarks.
Oh, jeez.
Okay.
So wait a minute. Is
right. So
for
so-
antimatter, does every particle in the universe have like an opposite
Yes.
particle?
yes,
Holy
Yes.
crap.
yes, yes. That's
Why?
what's it's profound.
How? Why don't we see it?
It is profound.
So
But who's you? This is what you said. There is something there that we don't know what it is, and the fact that it's there, and I can't explain it to you beyond the, I'm making up. This is how it works. If we had it, if, I can't show you it, but if, and then here's the mechanics of if, but that's it. And it's profound. It's like, that's like saying domina it's profound. Domina. It's like,
Okay.
I just made it up, by the way.
there is an actual opposite world. There's an actual opposite world. There's an opposite universe.
I'm getting there. We produce antimatter all the time in the laboratory. How do you make matter? Get a pocket of energy that is enough so that if you converted that energy back to matter, you can make an entire particle out of it.
Okay.
Okay? So in other words, we are illuminated by lights, stage lights, literally.
Right. Exactly,
okay?
yeah.
All right. Those photons are visible light.
Absolutely.
If you say, well, there's an energy of a visible light photon, let me convert it, uses equals mc squared, see how much mass that would get me. If I converted it into matter, there is no particle light enough for visible light to turn into.
Got you.
This is a very important fact. I don't want to move forward until I hear that you understand this.
So here's the deal. But there's no. Say that again. I just got to get
Okay?
it.
We've got
Yeah,
photons
photons.
moving through the air.
Right.
Okay? Here they go.
They're kissing me right now.
There you are. Okay? Grab one of them and say, can you be a particle? A matter particle? Well, let's find out. How much energy do you have, Mr. Photon, Madam Photon? Plug that into the equals mc squared formula. See how much mass equivalent it is. If that mass equivalent is below the lowest mass particle, it will never make a particle. It'll just travel through the universe forever. If you have a photon that has enough energy so that when you plugged it into this formula, you have enough mass to make a particle, it can spontaneously turn into matter.
Damn!
Yeah. Yes. Spontaneously.
That's crazy.
Wait. So now, because if I'm going to make matter, if I'm going to make like a electron,
Right.
I can't just make an electron out of energy because I started out with no net charge.
Right.
I started out with no net particles. So if I'm going to make particles, they have to add up to nothing. Okay? So if I don't have a charge to begin with, if I make an electron, you damn sure I better make a positron.
Right.
So the positive cancels the negative. If I'm going to make a matter particle, you damn sure I got to make an antimatter particle because matter and antimatter cancel out.
Look at that.
By the way, if it's just sitting there and it makes a pair and the electron goes off in this direction, where does the positron have to go?
The other direction.
The exact opposite direction.
Right.
So that the momentum cancels.
Exactly.
So let's go back to the early universe.
Okay.
It's hot.
Super hot.
Super hot. The energy's making matter, antimatter particles.
Right.
And then they find their antimatter matter counterparts and become energy again.
Right.
It's an energy matter antimatter soup.
Right.
It's roiling.
Yeah.
There it is. They separate here, they find another one.
Right.
There it is. Okay? Quarks.
He's basically explaining steam and like water.
anti-quarks, electrons, anti-electrons. There they go. Now the universe expands. And as it expands, it cools. So now the energy reaches a threshold where it's not high enough to make
Like
particles
anymore.
So, hold on. But how about the particles you did make? There's whatever's left over at that moment that the energy's not making matter anymore. How about the matter that's there? Well, you had equal amounts of matter and antimatter.
Right.
They would find each other, annihilate, become photons again. So, if the universe behaved as we expected it, there would be no matter anywhere in the whole universe. Because everything would have become photons cooled below the particle making energy.
Okay. Okay.
It would be a universe of just light.
Okay.
Cooled below the particle making energy.
That right there. He always makes that face. It's like he's coming, basically. He always, whenever he says something that he feels is profound, he always has that face.
Okay. Okay.
Quote me.
It would be a universe of just light.
Oh, that sounds lovely.
With no people, no
yes,
planets.
I love that.
No
And
stars, no galaxies.
Right.
No black holes.
Right.
Nothing. But that's not what happened. Somewhere in there, one of these reactions, out of 100 million of them, one of them made a matter particle with no antimatter particle. And we do not have an understanding of that.
I was about to say, but you can't do that.
I know. It's not allowed.
And that doesn't make any sense.
But it happened. So what happens? 99,999,999 particle-antiparticle pairs annihilated to make light.
Right.
And one was left over.
And goes, what happened?
What happened?
Hey,
hey,
where'd everybody go? What's going on, man? Where am I? What is it? Oh, it's dark in here, man.
It's dark in here.
What happened to our light? The light.
No. So the light is there.
Yeah,
but they don't have an antimatter counterpart.
But they can't. Right. So now they're stuck.
They're stuck.
They're stuck.
They're stuck. Literally stuck. So the universe is birthed with 99,999,999 photons for every one
particle.
Correct.
And that one particle should have been a photon.
A photon.
But something happened.
It was an
It should have gone back up.
It was symmetry breaking.
Right.
Happened in the early universe.
And so now
and everything we know and love, touch me here, touch.
Hey, man.
All of this.
Oh, look at that. Shouldn't even happen.
Is from all of that.
Nothing. None
all
of this
of that is from those
that
one particles left over.
All right,
correct.
I'm done.
What? No,
I'm done.
Okay.
That's crazy.
That happened in the early universe, and we don't understand it. So you can ask, well, could there, maybe the antimatter is still there?
This is a theory. This is what someone came up with, probably to get laid or something of that sort. And we ran with it. The hell? It's not recording. What?
But we can't see it or interact with it. Are there antimatter galaxies looking like an ordinary galaxy? But we see galaxies colliding all the time, and they're not annihilating.
Right.
No,
Right.
there's
Yeah.
circumstantial evidence that we are in a matter universe, and the antimatter is just simply not there. So maybe there's a whole other universe. Maybe I don't know. Maybe this asymmetry broke the bounds of this universe and put the antimatter in another universe. So they're an antimatter universe having the same conversation.
Ugh, my head
They say,
hurts.
we're all antimatter and we're happen to the matter.
Exactly.
Except they wouldn't be calling themselves anti because that's
No.
they
Yeah.
just matter.
Yeah, we're matter, and what happened to those other matter? That's insane.
So if you're going to cross a universe, bring a coin with you and flip it to the other beings. If they annihilate, that's an antimatter universe.
That's right, because your matter definitely will annihilate.
If our antimatter, if it's somehow mysteriously tunneled into another universe, who knows what happened to it?
Right.
We don't know. But
Because
we are in a matter universe.
they would be our antimatter.
Yes, the whole universe would be
So
our antimatter.
anybody we meet from that universe, we come together. We like, yo, what's up, man? Give me some love. And boom, done. Oh, that was fascinating.
I'll give him that. All right, we got to go.
I love it.
Okay.
I love it.
Yet
So,
another.
If you don't see us again,
Because we found.
you know what happened. We found some antimatter.
All right, I'm signing off here from my office at the Hayden Planetarium. This was yet another Star Talk Explainer. Keep looking up.
Antimatter is extremely rare in the observable universe, but researchers just discovered the heaviest antimatter hypernucleus. Antimatter has challenged established paradigms for nearly a century now, showing us how critical thinking fuels scientific and even societal progress. And thankfully, our partners at Ground News make that much easier to do. Reportation of available human and intellect.
Man.
We come together.
Okay, well, this was a waste of time. That's all it was. Because I don't know what the fuck antimatter is still. You're just, all you told me is you've invented a negative and threw it over there and just like, we're like, wow! Like, that's it. And what you're doing in the lab, and like your system, it works, but it's not enough. It doesn't actually work. It works to the nerds because it's basically a language, and it works like math works, in that it doesn't. Basically, and that's why there's two maths. There's math that works and math that doesn't work. But yeah, I gotta do more research on the antimatter because it's, to me, not real. So yeah, that's it as far as that goes. So man, okay, I'm out of here. So thank you for watching, guys. But as far, I don't know. Like, what is antimatter? What the fuck are they talking about? And if we touch it, it blows up. And yet they're working with it in a like, I don't, what the fuck? I think it's just something that scientists said, and they ran wild with it, and they can't prove a damn thing, and it doesn't work. And there may be some process to it, and some understanding at a point. It's like learning the violin and the language of playing a violin. Like, yeah, you can do that, but like, why? What's the point? Like, you're not doing anything other than playing the violin, and like, someone can play the violin without, you can learn a whole different way to play the violin and play the violin. Like, it's like a language, right? It's exactly like a language. Like, you could speak English and you could speak German. It doesn't mean that it actually works that way or it operates that way. But it's just, that's just how we communicate it. So that makes me wonder what the fuck it actually is. Beyond the, I need to see it. Let me see. Show me a picture of antimatter. The trash has worth $62.5 trillion. Where is it? Hmm. What did I do? Hmm. Damn. Okay. What the hell? That's weird. That's weird. Wait, there was one thing that I was supposed to do. Hold on, do that. It's fine. I don't know what the fuck we did, but it was an accident. Oh shit. God damn it. Anyways. So I don't know what the fuck antimatter is. All I know is basically they claim that A has an it's magically becoming A minus or A plus, and that there's negative matter that's A plus or A minus, and it's somewhere, and if we touch it, or if it touches matter, it blows up. It's basically. And supposedly somewhere in this world, someone has this little thing that has 1 gram of antimatter that's worth $65 trillion, apparently. And they supposedly use it in hospitals, antimatter. I don't know. That doesn't explain shit. But anyways, I'm gonna call it because I don't fucking know what the other. It's so stupid. Okay, alright, I'm out here. Peace.